So in this video today, we're going to talk about some other characteristics of polynomial graphs. So this first one says, let's draw a graph of a third degree polynomial with a negative leading coefficient. Some of the questions we should be asking ourselves as we're thinking about this is, how many times does a graph turn? How many zeros do you expect the graph to have? And what is the end behaviors of the graph? Okay, so a third degree would be an x to the third. So that would be an x. So it says, how many times will the graph turn? So we know that the graph is going to turn one time less than the degree. So, and it says, how many zeros do you expect the graph to have? Well, if it crossed the x-axis, it would have 3 zeros. And then it said, okay, so if it's a third degree, I'm going to start up here and I'm going to go down there. Now, I did mine a little bit different than probably most of y'all. You guys probably made it cross all 3 times at the x-axis, but you don't have to do that to get a third degree negative leading coefficient. Now, so look here. If I were to draw a line up here, notice I've got 3 places where it crosses this horizontal line. So that would be the equivalent if I'd move the whole graph down. Okay. So also notice that I have a min here, over here, a min and a max, right? So those are our 2 turns, right? And we add 1 to that, and that's our x to the third. And this graph ends down. So over here, when we're at infinity, the graph is going down. So that's why it has a negative leading coefficient, okay? So what we talk about next is, I would like you guys to look at these graphs here, and I would like you to tell me what their degree is and what their leading coefficient is, okay? So I'm going to do the first one with you guys and have you guys do the other 2. So again, if we were to count our mins and maxes, so we've got 1, 2, 3, 4. Remember, if I add 1 to that, that would be a 5th degree polynomial, right? Now here's another way to look at it. If I draw a horizontal line across the whole graph, okay, how many times does it intersect? 1, 2, 3, 4, 5. So both ways we proved that this is a 5th degree polynomial, right? And then the leading coefficient, if the graph ends up, it's positive. If the graph ends down, it's negative. So this would be positive, okay? So now I'd like you to do the other 4 and come back to me when you're done. All right, so on this next one, again, we've got 1, 2, 3, 4, kind of 5. But we know this can't be a 5th degree, right? Because it's both ending down, which means it's going to have a negative leading coefficient. But so this is going to be a 6th degree. And the reason it's going to be a 6th degree really is because there's 3 right here. We call this a slide, when it goes flat across the x-axis, and that would actually be equivalent to 3. And if we did the 1 here, the 2 here, and the 3 here, and add the 3 to it, that would make it 6. Yes, that one was supposed to trick y'all, okay? All right, so look at the next one. This one is, again, 1, 2, 1 min, 1 max, right? And add 1 to that, so that would be a 3rd degree. And how does it end? Down, so this is negative. This one, we've got 1, 2, 3. Again, if we add 1 to that, it would be 4th degree. And again, if we drew a line up here, we would see that it crosses it how many times? Yep, 4 times, okay? So our leading coefficient here, because it both ends up, is going to be positive. Now what I'd like you guys to do is look at the end behaviors. Okay, so on this graph, as x approaches infinity, as I go towards this direction with my graph, where is this headed? Yes, it's headed towards infinity, so we're going to put infinity here, right? And as we head towards negative infinity over here, that's when x approaches negative infinity. Where's the graph headed? Look right here. It's headed towards negative infinity, isn't it? That's our f of x. F of x and y are the same thing, so this is headed towards negative infinity. And just recall that when they're odd functions, one of them is going to be infinity and the other one's going to be negative infinity. Now, when it's even, they're going to head the same direction, okay? So let's see if you guys can do B, C, and D and come back to me when you're done. Okay, this one's obviously even, and both are headed down, so it's negative infinity, negative infinity. Our next one, it says as x approaches infinity, where does f of x approach? So again, as I'm going this direction, where's it headed? Towards negative infinity, right? Because negative infinity is down here, right? And then as I head towards negative infinity over here, where's the graph headed, y'all? Yes, towards infinity up here, right? This next one, pretty easy, right? Because no matter which direction I go, whether I go towards infinity here or I go towards negative infinity, where's the graph headed? Infinity, right? So, all right, now we're going to talk about our new concept for the day, and this has to do with intervals of increasing and decreasing, okay? So, we're not going to worry about this down here. So what do you think it means if the graph is increasing or decreasing? So basically, if I get on the graph over here at negative infinity and I start on the graph, where's the graph going, y'all? Yes, it's going down. So don't you think it would be decreasing? I agree. It's decreasing to what point? Right here. Yeah, so it's going to decrease from negative infinity to what? What was that point we just saw? Negative 1.414, right? Now, what happens right here from this point to up here? It's increasing, right? So this over here was decreasing, right, y'all? And I'm going to do a bracket here. Now, I need y'all to listen to me. So when I have a comma, the next thing I'm going to do is going to be a bracket. Can't have a comma and a bracket, okay? The bracket means it's included. The comma means it's not, okay? So don't worry about this down here because it was wrong. But anyway, so let's just talk about this. So now this is going to start at negative 1.414. And where does it go to? Right here, which is what? 0, okay? So now I'm just going to close this with a parenthesis so you guys can see. Now I could have closed it with a bracket. So then the next one again, notice what is happening to this next one right here. It's decreasing again, right? So, well, let's talk about that last one. This one was increasing, right? So our next one is decreasing. So again, I'm going to put a bracket here because I had a parenthesis there. I can only put one or the other. And I'm going to put 0 here. And then where did that go to? What was this point down here, y'all? Yes, 1.414, right? Now, again, I'm going to close a bracket here. Now, that means the next thing I'm going to do is a parenthesis. So the key here is if I have the same point, I got to have a comma at one set of parentheses and a bracket in the other. It doesn't matter which one is which, though, okay? So our last one, I'm going to do a comma here, and I'm going to start with that point 1.414. And here again, y'all, what's happening to this graph? Yes, it's increasing, right? So it's going to be 1.414 onto where? What's over here on the right, y'all? What's over here? Is it infinity over here? So yes, this one's going to go on to infinity, okay? So now when we talk about our, and so this one, the black one there was decreasing, right, y'all? And this other one right here was increasing, yes? So now what we're going to do is write our statement. So our statement for decreasing is going to be, from negative infinity, and anytime we have an infinity, we always put a parenthesis, okay? Comma, negative 1.414, okay? And I'm going to put my parenthesis there. And now I'm going to join that. I'm going to create a union with that in the other decreasing. So our other decreasing was 0, comma, 1.414. So this one I close with a bracket again as well. So now we're going to talk about our intervals of increasing, okay? So our intervals of increasing were from negative 1.414, comma 0, and we had a parenthesis there. And then I'm going to union that with the set of numbers for my other set of increasing, and that one's going to be 1.414, comma, onto infinity. Now, I need to talk to y'all about a couple things here, okay? So notice here, over here, that whenever I have the same number in both sets of parentheses, one has a parenthesis and one has a bracket, okay? Same here, same here. Y'all see that? So it doesn't matter which one has a bracket and which one has a parenthesis, but it's either or, okay? It either has a parenthesis or it has a bracket, okay? And then the other point is at the ends here, guys, I'm always going to have a parenthesis and a parenthesis. Y'all see that? Where there's any kind of infinity, okay? All right, let's do another one together. Wow, this is moving really slow, y'all. Okay, so it says find the intervals of increasing and decreasing. Use Desmos.com to determine the intervals. So go ahead and go to Desmos.com and put this in there, and then we're going to look at what it does. Okay, so now I'm going to pull this down because I already put the graph in here. Maybe if I can grab this. Okay, there we go. So notice here, what is the graph doing from negative infinity over here, y'all? Negative infinity is over here and positive infinity is over here, right? So what's the graph doing from negative infinity to right here? Isn't it increasing from negative infinity to where? 0, right, y'all? So I'm going to put a parenthesis there. But then over here, when I see it decreasing, right? So isn't it decreasing right here, y'all? Yes. So it's decreasing from where? From 0. And I'm going to put a bracket on that one because we didn't include the 0 on the one on the left. We are going to include it on the one on the right. And so then that's my decreasing. Okay, so my increasing was from negative infinity to 0. And my decreasing was from 0 to infinity. Okay? So don't make this complicated because basically is the graph going up or is the graph going down? That's what we're talking about. Okay? So let's go on to the next one. This one says, again, find the intervals of increasing and decreasing. This time we also are going to find the roots and the end behaviors. Okay? So let's look at this graph. And I'm probably going to have to, roll down a little bit so we can see the whole thing. So there's the graph when I graph it. Okay? Let me pull it up a little bit. So notice this is my 0 down here. This graph, you're going to have to zoom way out to see this. So again, though, what do you see? As we're coming in from negative infinity over here, y'all, what's happening to the graph? Isn't it decreasing from negative infinity to where? Again, 0. This time I'm going to do a bracket because it doesn't matter, right? And then it's increasing from where? Parenthesis, from 0 to infinity, right? So when we write our decreasing and increasing up here, that's what it's going to be. So we're going to put increasing from 0 to infinity, right? And it was decreasing from negative infinity to 0, and we're putting our bracket there, okay? So now when we're talking about roots, y'all, we can't see where this graph crosses the x-axis down here, so that means it must have imaginary roots. So let's talk about how we're going to find those. So don't we find those by doing x squared plus 81 and setting that equal to 0? So that would be x squared equals negative 81. And then aren't we going to take the square root of both of these sides? So that's going to be x is equal to plus or minus the square root of negative 1 times the square root of 81. And hopefully all of y'all can see that this is going to be x is equal to plus or minus 9i. So those are our roots. Now this is the deal, guys. We knew that it was not going to have real roots because it did not cross the x-axis. Now let's talk about our end behaviors, and that means this right here. Where does the graph end? Yep, infinity and infinity, okay? So I'd like you guys to do this one on Desmos and come back to me when you're done, okay? Again, remember you're looking for the interval of increase, decrease, roots, and behaviors, okay? So, all right, now what I'm going to go ahead and look at the graph here. I'm going to scroll up a little bit so I can see the whole thing, okay? So notice I clicked on my points, right? So here this time, notice that our graph is doing what? From left to right. So this is from negative infinity. What's happening? From negative infinity to 2, right, y'all? There's our 2. What's happening? It's decreasing, right? And then from 2 to infinity, what's happening to it? It's increasing, right? So when we're talking about our increasing, it's going to be 2 to infinity, right? And then decreasing is going to be from negative infinity to 2. And then our roots were up here, guys. There are these points right here. This point right there and that point right there, which were negative 2 and 6. Remember, our roots are our zeros of our function. And then what's happening at our end behaviors again? Here. This is an even, right? So it's going to be infinity and infinity. Okay? Go ahead and do the next one and come back to me when you're done. So here again, I went ahead and pulled in the graph. There's the graph. I expected this one to look like this, right? So it has 2 decreases and 1 increases. Okay, so look here. So we're going to decrease from here to here, right? So that's going to be negative infinity to what was that down there? Negative 0.889. So it's going to decrease from there. And then what happens to this next piece right here, guys? What happens here? This is increasing, right? So it's going to increase from where? So that was decreasing. Okay, then we're going to increase from negative 0.889 to where? What's that right there? Yeah, to 0. Okay, so I'm going to close it with a parenthesis there. Then I'm going to pick it back up over here with another bracket because I did a parenthesis with the other one. And what's happening to this one over here, guys? Again, what's happening? Yep, it's decreasing. And it's decreasing from where? From 0 on to where? What's out here? Infinity, right? That's what's out there to the right. Okay, so now we're going to write these. So again, this was increasing here and this was decreasing here. So we had 2 decreasing and 1 increasing on this one. So our increasing was negative 0.889, comma 0 with a parenthesis there. Our decreasing is going to be negative infinity to negative 0.889, and I'm going to put a parenthesis there, and then I'm going to join that, union that, with our other decreasing, which has got a bracket here and then an infinity there. Okay, and remember, wherever you have an infinity, you're always going to have a parenthesis, right? All right, I'm going to erase this right here so we can talk about the root of our function. So this is the only place, guys, where that graph crosses the x-axis. Now, we might have some imaginary roots, but this is the only real one, okay? So it's negative 1.595, okay? And then what's happening here with our end behaviors? Now, whoa, slow down, look at this. So as x approaches negative infinity, this time we're talking about going this direction, y'all. Where is y headed? Exactly, towards positive infinity. Okay, so be careful. Watch how this question is being asked. Okay, and then as we're headed towards infinity now, what's happening? Where's the graph headed? Yep, towards negative infinity. Okay. All right, go on to the next one and come back to me when you're done. So here's the next one. Again, I went ahead and graphed it for y'all, so I'm going to pull it off here. Notice that it does, I'm going to scroll down here. It's got 1, 2, 3, right? And this time, and I mean, you guys should have been able to guess this. It's got 2 intervals of increase and 2 intervals of decreasing, right? So again, let's look. So from negative infinity out here to this point down here, which is negative 2.5, y'all see that? We're just looking at the x value. So to negative 2.5, what's happening? Is that decreasing or increasing? Yes, decreasing, okay? Then we're going to talk about our next interval. So what's happening here, y'all? From here to there. What's happening? So I'm going to put a bracket here. So from negative 2.5 to 0, what's happening, y'all? And I'm just going to close that with a bracket. Yep, that one's increasing. Okay, now what about the next one? This one right here, decreasing again, right? So this one, I'm going to put a parenthesis. So that's going to be from 0 on to what? What this was at 1, wasn't it, y'all? Comma 1. So I'm just going to put another comma here, okay? And then we're going to pick it up again over here, and that's another increasing, isn't it, y'all? Let me put that one back there. Okay, so this last interval is going to be increasing as well. I'm going to do a bracket here, and I'm going to start that at 1, and I'm going to go on to infinity. And remember, I'm always going to close that with a parenthesis, okay? So when we talk about our intervals of increase and decrease for this one, our intervals of increasing were from, okay, so let's talk about this again. This was decreasing, this one was increasing, okay? So from negative 2.5, comma 0 bracket, right? And then we're going to join that with our other increasing, which was 1, comma 8 with a parenthesis. Then our decreasing were at from negative infinity to negative 2.5. We have a parenthesis there because we had a bracket for the one before, and we're going to join that with the other group of decreasing, which was from 0, comma to 1, right? Okay, now let's look again. Let me erase this. And let's look at our x-intercepts, which are our solutions, okay, guys? So these are our solutions right here, where the graph intersects the x-axis. So this is going to be negative 3.56 and 1.84. Sorry, I almost put a negative. 1.84. Okay, now what's happening with this graph? If you were to put arrows up here, we would be able to say that this is going on to infinity. Those are our end behaviors, right? And on to infinity, okay? So on this next one, it says factor first when possible, then solve and look at the graph to verify your solutions. So let's see, if we were to take x squared, there's the factors that are x and x. What are the factors of 9 that when added together give you a 6? Wouldn't that be 3 and 3? Right? So that's going to be plus 3 and plus 3. Now, the way we verify this is by, okay, so if we were solving this, we're going to say x plus 3 equals 0, right? So our x-intercept should be at -3, shouldn't it? Okay, and so what we do is we go ahead and put that equation in our Desmos, and indeed, notice it has one solution at -3. So this is the way you guys can check these, okay? The next one, same thing. Factor first when possible, then solve and look at the graph to verify your solutions. Okay, so can we factor this one? We can use bottoms up, right? So we're going to multiply the first two. I guess I can't write on that yet, so I'm going to do it above. Okay, so we're going to get -8, right? So we're going to look for the factors of -8 because we're going to multiply a times c that add up to be 7. So that's going to be 8 and -1, right? So we're going to do this like this. X plus 8, x minus 1, right? And then we're going to divide both of those by our 2, remember? And when we can't divide it, we're going to do bottoms up. So this is going to be x equals 4, sorry, x plus 4, our factors. X plus 4, and remember, this is going bottoms up, right? So this is going to be 2x minus 1. Now, if we set each of these equal to 0, then I'm going to move this down just a little bit so we have a room to work. This is going to be x equals -4, right? This is going to be 2x equals 1, so x equals 1/2. So let's see if we can verify that here, okay? So yep, -4 and 0.5. See where those zeros cross right there, guys? Okay, so let's do this other one. So what about this one? It doesn't have a GCF, that's what we always want to look for. And then we are going to multiply first and last, a and c, 45. Are there any factors of 45 that add up to be 8? So are there, y'all? 45? I don't think so. So 9 and 5, 1 and 45, 3 and 15, 5 and 9. Nope. So what are we going to have to do here? Aren't we going to have to do our ABC and use our quadratic formula? Okay, so we're going to do negative b, which would be -8, plus or minus the square root of b squared, which is 8 squared, minus 4 times a times c, all over 2 times a, right? See if I can move this over here so it's out of our way for the moment. It's just going to be 2 times 3. So that's going to be -8 plus or minus the square root of 64 minus, that's 120, right? Ooh, this is going to be imaginary, y'all, right? So I'm going to end up with x equals -8 plus or minus the square root of -116 over 6. So that's going to give me, let's see if I can give myself a little more room. X equals -8 plus or minus, I would do the square root of -1. I'm pretty sure that's divisible by 4, and then 29. And then this is all over 6. So continue to simplify. So this is going to be equal to -8 plus or minus 2i square root of 29 over 6. Everything's divisible by 2, isn't it, y'all? Yep. So this is going to end up being, my final answer will be -4 plus or minus I square root of 29. I can't tell. Oh, yeah, I can get rid of it. Square root of 29 all over 3, because everything was divisible by 2. Okay, and notice that it did not intersect the x-axis down here. Okay, so that's why there are imaginary solutions. All right, so the last one here says extension, use Desmos to find the factors. So if we're looking for the factors, again, y'all, I go ahead and put this equation in Desmos, and all I'm looking for are these zeros. And remember, I'm going to make them opposite of what they are. So this first one right here would be x plus 5, right? This next one would be x plus 1. The next one would be x, because it's x equals 0. Where's that next one? I'm trying to see. X minus 3. Yep, so that's going to be x minus 3. Remember, they're always going to be opposite when we write them as factors, and this is going to be x minus 7. So that's what our factors are if we were to pull them from this graph.